Okay, so today on Notes 8.2, we're going to be looking at another law. Law 7 states that if we have a negative exponent, we'll take that base and the negative exponent and we'll move it. So if it's, on this example, if it's here, we would move it to the bottom to make it 1 over a to the positive n power. If it was on the bottom of a fraction, in order to make it positive, you would take the base and the negative exponent and you would move it to the top. Okay? It does say, note, a negative exponent does not indicate that you have a negative number. So for example, if you have 2 to the negative 2, that does not mean that it's going to be a negative 4 for your answer. Okay? Alright, so we always want positive exponents in our answer. So if you look at number 1, those 5s are bases and not coefficients. So we're not going to multiply them. We're going to keep the base the same. And when you multiply, we talked about yesterday, you add the exponents. Negative 4 plus 3, we get negative 1. Okay, so we have a negative exponent. We don't want negative exponents. So I'm going to take the base, which is 5, the exponent, and move it. Okay? If there's nothing left, we're going to put a 1 on top. Over, now it's 5 to the positive 1 power, and that just equals 1 over 5. So we're using laws of exponents from yesterday, and then we're just adding to it with negative exponents. Okay, so look at number 2. The 2 inside parentheses is a base, so it stays as 2. And then we're going to distribute that exponent on the inside. When you distribute an exponent to another one inside parentheses, we multiply. So that would be negative 6. Notice that base has a negative exponent, so I'm going to take it and move it to the bottom. I'm left with a 1 because there's nothing left on top. And now it's 2 to the positive 6 power. Remember we talked about yesterday, if your base is a number, your exponent is a number, you need to evaluate it. So we need to go one more step. 2 to the 6th power will equal 64. So the answer would be 1 over 64. Alright, 3. The 8s, those are bases. So we're not going to multiply 8 times 8. We're going to keep the base the same. Okay? So when we multiply and the bases are the same, we add the exponent. So on top here we would have 8 to the negative 8th power over 8 to the negative 9th power. So now notice that we have bases that have negative exponents. So we're going to take this 8 on top, move it to the bottom to make that a positive 8 power. And then we'll take that bottom base and exponent and move it to the top because that is a negative exponent also. So now we're going to have 8 to the positive 9th power over 8 to the positive 8th power. Okay? Alright, so now notice that we're dividing and bases are the same. So I'm going to keep the base the same, which is 8. And then remember when we're dividing, we subtract exponents. So that's going to give me a 1. So that would equal 8. Alright, 4, we're going to distribute that negative 3 to both of our terms inside the parentheses here. So that would be 5 to the negative 3rd over 4 to the negative 3rd. And then we're going to make our exponents positive. So I'll take the base 5 to the bottom and this base 4 to the top because they both have a negative exponent. So I'll have a positive, or I'll have a 4 to the positive 3rd power over 5 to the positive 3rd power. Now, on this one, notice the bases are not the same like on number 3. Those bases were the same. These are not, so we can't subtract the exponents here. Okay, so we need to actually evaluate that. So 4 times 4 times 4, you would get 64. 5 times 5 times 5, you would get 125. If you end up with a fraction, make sure that you look to see if it can be reduced. And we cannot reduce 64 over 125. So that would be your answer. Okay, so let's look at 5. 5, 2 is not a base. It's a coefficient. So do not forget to distribute that exponent to the coefficient. So we need to do 2 to the negative 2 power. And then I'll also distribute that exponent to another exponent. So we need to multiply those together. So that would be x to the negative 6th power. Okay, so remember I talked about at the beginning, 2 to the negative 2 does not mean that equals negative 4. We have to make that exponent positive before we can evaluate it. So I'm going to take the base 2 and move it, and also the x, because those are both, or they both have a negative exponent. So if there's nothing left on top, there's a 1. Bringing those two down, we're now going to have 2 squared x to the 6th. We can now evaluate that 2 squared, so that'd be 1 over 4 x to the 6th. Alright, 6. Notice we're multiplying fractions, so we're going to do top times top, bottom times bottom. If you wanted, you could move the bases that has negative exponents first and then multiply, but I'm going to go ahead and multiply first and then get rid of the negative exponents. Okay, so notice on the tops, 5 and 3 are both coefficients. So we need to actually do the operation that it's telling us to do. We're going to multiply them. So that's going to be 15. Then multiplying the x's together, because those bases are the same, we're going to add the exponent. So that would be x to the negative 7th power. And then multiplying those y's, we get y to the 8th, because we add the exponents. Looking at the denominators, 8 and 6 are coefficients, so multiply them. That's going to be 48. And then notice I have an x to the 5th, but I don't have another x, so it stays as x to the 5th. And then I have a y to the negative 4th. From here, I'm going to look at those coefficients in front. I need to see if I can reduce them. Those are coefficients, so we do exactly what it tells us to do. So divide, so we're reducing. 3 will go into both, so that would be 5 over 16. And then I'm going to take my bases that have negative exponents and go ahead and make them positive. So if you look at the top, the base that has the negative exponent is the x. So I'm going to move that to the bottom. I'm not taking that y on the top to the bottom because that's a positive exponent. Looking at the bottom, the only base that has a negative exponent is the y. So I'm going to move that to the top. So we already have a y to the 8th on top, and we're bringing up another y, so I will end up multiplying those together. The bottom, I already had an x to the 5th, and I'm bringing down an x to the 7th, because now it makes it positive 7. So here now we're going to multiply the y's, multiply the x's, because the bases are the same. So on top I'm going to have 5, we add the exponents, y to the 12th, over 16, x to the 12th. Notice y and x are not the same, so we can't divide those, so that would be our final answer. Okay, looking at 7, it's very similar to 6. So we have fractions, multiply the tops, multiply the bottoms, and then we can get rid of those negative exponents. Or if you prefer, get rid of the negative exponents at the beginning. Okay, so negative 2 and 4 are coefficients. So multiply them, we get negative 8. Multiplying the x's, we add the exponents, we get x to the negative 4th. And then the y's, we get positive 1, which we don't have to write there. Denominators, multiply those coefficients, so you get 72. We have an x that we can't multiply with the y, so I'll bring it over and then bring over that y term. So same thing as the last one. Let's go ahead and reduce our coefficients. That will equal negative 1 over 9. And then I'm going to take the base that has the negative exponent on top, which is only x, and move it to the bottom. Then notice in the denominator, x and y, both of those bases have a negative exponent, so we would move all of that to the top. So I already had a y on top, and I'm bringing up an x cubed and a y to the 5th. And I brought down that x to the 4th. Now notice we can multiply those y's together. So I have a negative 1. If you have more than one variable, put it in alphabetical order, so that would be x cubed. And then we're multiplying the y, so add the exponents, y to the 6th over 9x to the 4th. now look, we're not done because notice that we have an x on top and an x on bottom. We can divide those because those bases are the same. When the bases are the same, we subtract the exponents. Notice if we subtract the top minus the bottom, 3 minus 4, we're going to get a -1, and we don't want a negative exponent. Okay, so I'll show you a little trick. If you're subtracting and you end up getting a negative, your answer will go to the bottom, which is where the larger exponent is, which is the 4. The reason for that, x cubed is x times x times x. X to the 4th is x times x times x times x. And then notice 3 of them cancel and you're left with 1 of them on the bottom. Okay, so we would have a -1y to the 6th over a 9x. And you don't have to write that -1 there. You can just write a negative. So that would be my answer there. Alright, let's look at 8. Notice we're multiplying fractions, but before we can multiply them, we need to get rid of those parentheses. So I'm going to distribute that to all of those variables there. I'm going to rewrite this first fraction. And then I'm going to distribute those. When I distribute those, an exponent to another exponent, we multiply them. That would be x to the -4th, y squared, and z to the -2 over z to the -6. Alright, so now this looks similar to what we had on 6 and 7. We're going to multiply the tops, multiply the bottoms. Notice this time we don't have coefficients, so that's fine, we don't have to worry about those. We're only going to be multiplying the bases that are the same. So we'll multiply the x's, so we'll add the exponents. So it'll be x to the -6. And then that would be y to the 5th. And z to the -3rd. Over x to the -3rd, y squared, and z to the -6. From here, you could divide the bases that are the same or get rid of the negative exponents, which is what I'm going to do. So notice on the top, the bases that have the negative exponent are the x and the z. So I'm going to only move those two down. And then on the bottom, x and z. So now on top, I'm going to have an x cubed, y to the 5th, because that was already there, and then a z to the 6th. The bottom, now I'm moving that x down, so x to the 6th. I already had a y squared, and then we brought down the z cubed. Okay, so we got rid of the negative exponents. Now we're going to divide. When we divide and bases are the same, we subtract the exponents. So 3 minus 6 on the x's, you would get -3, which means, remember I told you it's always where the larger one is if you want it positive. So that x cubed would need to go in the denominator. Again, if it helps you to write it all out, 3 of them cancel and you have 3 left in the denominator. Okay, so then the y's, 5 minus 2, we get 3, so that's going to be good to put on top. And then z, 6 minus 3, we get 3. So that will also go on top. So there's your final answer. So this is using all of your laws of exponents to simplify your expressions.